Alright, today we'll be discussing Linux performance troubleshooting commands that Netflix uses. The 5 commands we'll review today will be the uptime command, vmstat, iostat, pidstat, and mpstat. So let's get right into it. Alright, so the first command we're going to be reviewing is the uptime command. Now, the uptime command is a quick way to view load averages on your Linux machine, and these load averages will capture typically processes that want to run, and it's most of the time when you see load average with high values, it's typically due to processes blocked by I/O. Most of the time it's disk. However, it just could be resource load in general. Maybe you have multiple machines in a virtual environment that are just consuming the underlying hardware, underlying CPU. These values on the bottom here, as you work left to right, are presented in 1 minute, 5 minute, and 15 minute intervals. And so if the first value you see on the left is higher than your far value on the right, that means you'll want to troubleshoot the root cause of that. And so we'll go deeper into some of these other commands further in this video. However, as you can see on my screen, I am pegging the CPU using the stress utility, and as the load average is climbing, obviously I'm causing it. However, just kind of a general rule of thumb, for one CPU core, you want to typically keep your load average to that value. So in this case, I have 1 CPU core on this machine, and so I expect the load average to be 1 or less. And that's pretty much it for the uptime command. Let's move on to our next command, which is vmstat. Alright, so the vmstat command is a common command found on just about every flavor of Linux. It prints a summary of key server statistics on each line, and here you can see I'm invoking the command with an argument of 1, and adding 100 will just print this output 100 times. So when a system is under load, as I just invoked here, you'll want to pay attention to several columns. For example, the R column is the column that will capture running processes. And as you see, this value of 1 or 2 means that there are 1 or 2 values or processes waiting to run. The other columns that you'll want to kind of make note of is the free, which is short for free memory, and this is actually listed in kilobytes. The SI and SO, which is in the middle of your screen, will stand for swap in and swap out. And then finally, the far right columns under the CPU, like the US, SY, ID, will break down values such as CPU wait, idle, IO, and stolen time. Alright, so let's discuss iostat. Iostat is a great tool for understanding block devices, disk, both the workload applied and the performance. As I put it under stress here, some things you want to kind of note and be aware of is the RS and WS, which indicate delivered reads, writes, and they're typically in kilobytes per second to the device. Wait is the average time for I/O in milliseconds. If this number is higher than normal, you probably have an issue with the underlying disk, so just something to be aware of. The other column you want to make note is the AVGQSZ. Even though I have this under load on my screen, there is a value of 0. However, if that ever were to increase, that would indicate that there are the average number of requests issued to the device. And I would say anything greater than 1 means you have evidence of saturation on the disk. And then I want to point out this final column here on the right is percentage util. Anything greater than 50% in this column would indicate that the device is performing poorly. And when you see values greater than 50 and upwards of 60, that means you probably want to dive deeper either within the underlying hardware, or you want to continue looking at system logs or application logs to try to hunt down what's causing the poor performance. So that's it for iostat. Let's move on. All right, and so for our fourth command, it's pidstat. Pidstat is like top, however, it captures a per process summary. The output, when invoked with an argument of 1, is displayed in rolling fashion every 1 second. And so for me, I like this better than the top command. When I stress the CPU, you can see on the screen that the stress utility is consuming 100% of the CPU in the percentage USR column. There's not a whole lot to go into detail for the pidstat command. I will say it is powerful and it provides a rolling history. So for me, this is a win-win. Let's move on to our fifth and final command. And that takes us to mpstat. So mpstat will print out the CPU usage breakdown on a per CPU. So while this example doesn't really do it justice, if we had multiple CPUs, you could see their usage broken down per CPU. And so while we have a 0 on the screen, if we had multiple, it would start with 0, 1, 2, and then onward. As you can see, I am pegging the CPU, so the percentage USR is pegged at 100%, and idle is at, well, now it's at 100, but it was at 0. And so if there was an imbalance of usage across CPUs, so for example, if CPU 0 said 80% and CPU 1 was fully pegged at 100% usage, that would be evidence of a single-threaded application. And so a discovery as such, I would personally escalate that to the developers or your engineering team. Okay, let's recap everything we just learned. So for the uptime command, it's a great tool for displaying system load averages. From left to right, your values will be in 1, 5, and 15-minute intervals. And then any value here should not exceed your total CPU count. If you have 1 CPU, your values should remain under 1. Moving on, vmstat provides key server statistics. Values in the R column captures queued processes. The free column will indicate free memory. SI/SO is swap in and swap out. And then US, SY, ID, and so forth will display disk. Moving on, iostat is a tool to understand block devices or disk. RS and WS columns indicate read and write values. Await is the average wait time in I/O. And then AVGQSZ is the average number of requests to a device. And then pidstat is a per process summary. It's similar to top. Why I like it more than top is the output is in rolling fashion, pretty much a historical view, and it's just simple. It's a simple command to run and gives you the output you need. And finally, mpstat. So mpstat will print the CPU usage breakdown per CPU. Multiple CPUs will be recorded in a historical view, and if the values don't match, this indicates there's an imbalance, which could be evidence of a single-threaded application. And that wraps up mpstat. So for everyone, thank you for watching. If you enjoyed this video, please hit the like and subscribe, and we'll be back with another video next week. Thanks.